But there are some very unusual facts about it that make us suspect that maybe it's technological. I can mention those because I regard it just like a potential black swan event.
The warning did not arrive as a public announcement, it arrived as silence. The moment XYSIM's live data stream stabilized, several screens in control rooms across the world froze, not from failure, but from disbelief. A diffuse X-ray halo was forming around 3I Atlas, expanding outward at a scale that made seasoned astronomers sit upright in their chairs. 250,000 miles wide, wider than the distance between Earth and the Moon, and growing. This was not background noise. This was not a calibration error. The signal was clean, persistent, and unmistakably real. An interstellar object, one that never formed around the sun, was glowing in high-energy X-rays inside the inner solar system. No comet observed before had ever done this. Not even close. Within minutes, private alerts began circulating between research teams. Phones buzzed, secure channels lit up. The math was rechecked again and again because the implication was deeply unsettling. X-rays require extreme conditions, violent particle interactions, energetic charge exchange, or processes that should not survive billions of years drifting between stars. Yet 3I Atlas was doing exactly that, quietly, steadily, as if responding to something invisible. The size of the halo made the situation worse. This was not a small reactive plume or a localized flare. The emission zone dwarfed the comet's nucleus by orders of magnitude, suggesting a massive interaction field, something extending far beyond the solid body itself. It meant the comet was not just shedding material. It was actively interacting with the solar environment in a way no existing comet model could explain. Scientists tried to apply known theories. Solar wind charge exchange, too weak. Fragmentation? The structure was wrong. Exotic ice chemistry? Not at this energy level. Every explanation collapsed under its own limitations. The more the data was analyzed, the clearer it became that this was not a variation of something familiar. This was a new category of behavior. What disturbed researchers most was timing. The X-ray emission intensified precisely as 3I Atlas moved deeper into the sun's influence, as if the object were not merely warming up, but switching on. Whatever mechanism powered this glow had remained dormant for untold ages, crossing interstellar space in silence, only to awaken now. And then came the realization no one wanted to say out loud. If this process could activate once, there was no guarantee it was finished activating. As XYSM continued feeding data, subtle changes began appearing at the edge of the X-ray halo, irregularities that didn't match any natural decay pattern. Something was evolving, something was changing faster than expected. And as scientists prepared to isolate the anomaly, a new signal began to emerge, one that would force them to question whether 3I Atlas was reacting to the sun or responding to something else entirely. The moment researchers tried to explain the glow, alarm spread through the data rooms. This was not how comets were supposed to behave. Every known comet inside the solar system produces X-rays the same way. Solar wind slams into dense gas, electrons swap charges, and a faint, predictable glow appears. But 3I Atlas broke that rule instantly. Its X-ray halo wasn't tight or localized. It stretched outward like a fog bank in space, ballooning across hundreds of thousands of kilometers, far beyond any model scientists had ever trusted. What made it worse was the structure of the glow itself. The halo wasn't smooth. It showed uneven layers, faint ridges, and ghost-like gaps, as if something was shaping it from within. Instruments showed the gas cloud was too thin, almost skeletal, to support this level of X-ray emission. By all known physics, the glow should have collapsed. Instead, it persisted. Strong, stable, expanding. Scientists checked for errors. They recalibrated sensors. They reran the data. Nothing changed. The signal stayed exactly where it was, doing exactly what it should not be able to do. That's when the conversation shifted. Quietly at first, then openly. If this was not standard charge exchange, then something else was feeding the X-rays, something no one had formally described. Two explanations remained, and both were deeply unsettling. The first. 3I Atlas carries a chemical composition unlike anything ever sampled, materials formed in an environment so alien that Earth-based physics only partially applies. The second. There exists an interaction mechanism between interstellar matter and stellar radiation that humanity has never detected before. A missing chapter in astrophysics revealed not in theory but in real time, racing through the inner solar system. Neither option was comforting. Both suggested the same conclusion, that the rules scientists rely on may only apply locally, and that objects born between stars obey a different logic entirely. If that was true, then every assumption about how interstellar visitors behave was suddenly unstable, and 3I Atlas was no longer just a comet. As the glow continued to spread and intensify, one final question began circulating among researchers, spoken softly but with growing urgency. If this X-ray halo isn't powered by the sun, then what exactly is driving it? It stopped being a visual mystery the moment the chemical data arrived. The numbers hit scientists like a warning siren. ALMA's sensors detected methanol and hydrogen cyanide pouring out of 3I Atlas at levels no normal solar system comet should ever produce. Not slightly elevated, not unusual, completely wrong. The ratios were so extreme that researchers double-checked the calibration, then checked it again. The data held. This wasn't contamination. This wasn't error. This was real. Methanol and hydrogen cyanide are not harmless traces. They are primitive molecules, the kind formed in violent, unstable environments. In solar system comets, they appear in predictable amounts shaped by billions of years under our sun. But 3I Atlas ignored those rules. Its chemistry did not match anything born here. What frightened scientists most was not just what was present, but how fresh it looked. These molecules should have broken down long ago. Radiation, heat, cosmic erosion, any one of them should have erased these signatures. Yet 3I Atlas was releasing them as if they had been sealed away, untouched, preserved in cosmic deep freeze since before our sun even existed. That pointed to a terrifying conclusion. Trajectory modeling placed the object's origin in the Milky Way's thick disk, an ancient region formed when the galaxy itself was young, turbulent, and chemically unstable. Back then, stars exploded more often. Radiation storms were stronger. Chemistry behaved differently. Matter formed under rules humanity has never observed directly, which means the material fueling 3I Atlas's massive X-ray halo may not be reacting to the sun the way modern matter does. The halo suddenly made more sense and became far more dangerous. If these ancient molecules are interacting with the solar wind, they could be triggering unknown charge exchange reactions, producing energy patterns no current model accounts for. That thin, enormous X-ray cloud might not be passive at all. It could be actively restructuring itself, driven by chemistry older than Earth. For the first time, scientists had to confront an unsettling possibility. China with 3I Atlas is not just an interstellar visitor. It is a frozen chemical record from a violent era of the galaxy, colliding with our solar environment in real time. And whatever is happening inside that halo is something humanity has never tested, never simulated, and never controlled. And just as researchers began mapping how these alien compounds behave near the sun, a new anomaly appeared. One that suggested the comet wasn't just releasing material. It was changing internally, right now, as if responding to forces no one expected. And that discovery would push the fear to an entirely new level. It was already running. By the time the alarms truly sank in, 3I Atlas was no longer approaching the sun, it was fleeing it. Instruments confirmed the numbers with chilling clarity. The interstellar object was accelerating outward at more than 210,000 kilometers per hour, fast enough to escape the sun's gravity forever. Its trajectory was not an orbit. It was a hyperbolic exit, a one-way path back into interstellar darkness. There would be no return. When 3I Atlas reappeared from behind the sun in late October, observatories across the planet snapped into emergency mode. Telescopes were retasked mid-cycle. Observation schedules were torn apart. Space agencies that rarely coordinate in real time suddenly shared raw data within minutes. The reason was simple and terrifying. The window was collapsing. This was not a comet scientists could revisit years later with better instruments. This was a vanishing anomaly, and every second it moved farther beyond reach. December 19, 2025 marked its closest approach to Earth, but close was a cruel word. It would remain far outside any possibility of interception. Too distant for probes, too fast to chase, close enough to observe but untouchable, like a message scrawled on a wall while the building burned. And still, the anomalies continued. As the object accelerated away, its emissions did not fade the way physics predicted. Instead, some signals intensified. X-ray readings fluctuated unpredictably. The diffuse halo stretched and thinned at the same time, as if parts of it were being stripped away while others were replenished. No known comet behaves like this while exiting the inner solar system. Scientists realized the brutal truth. Every missed hour meant permanent ignorance. Calibration errors could not be corrected later. Spectral gaps would remain gaps forever. If an instrument malfunctioned, that data point would never be replaced. There would be no second pass, no long-term study, no return mission. What humanity learned in these weeks would be all it ever learned. The pressure inside control rooms became suffocating. Researchers spoke in clipped sentences. Decisions that usually took months were made in minutes. Some teams began working around the clock knowing exhaustion was irrelevant compared to the stakes. Because if 3I Atlas carried answers about interstellar chemistry, unknown energy processes, or something far stranger, those answers were already slipping away at impossible speed. And as the countdown to December 19th accelerated, a darker question began to surface among scientists, unspoken but unmistakable. What if the most important signal hadn't even appeared yet? What if the object was saving its final anomaly for the moment it crossed the last observable threshold, just before disappearing forever? That fear set the stage for what came next. The shock did not fade. It multiplied. The X-ray halo was not an isolated event, it was the breaking point. Scientists watching 3I Atlas realized this object had been misbehaving long before the X-rays appeared, and now every earlier anomaly snapped into focus with terrifying clarity. Since its discovery in July 2025, the interstellar visitor had been quietly violating expectation after expectation, each one logged, debated, and then uneasily set aside. Now, those dismissed warnings were impossible to ignore. The comet showed multiple unexplained jets, erupting without the usual triggers of solar heating or rotational stress. These outflows did not behave like normal cometary gas plumes. They switched on and off abruptly. Some appeared on the night side, where sunlight could not drive activity at all. Instruments recorded no matching increase in water vapor. No familiar chemical signatures. Whatever was venting from 3I Atlas was not following the rules. Then there was the color. Instead of the neutral grays and faint blues expected from icy bodies, 3I Atlas reflected a deep, unnatural red, a hue typically associated with heavily processed surfaces, radiation-altered materials, or complex organic compounds formed over extreme timescales. But this object had only just entered the solar system. There was no clear explanation for how its surface had already reached such an advanced, altered state. Even more alarming was its extreme negative polarization, a rare optical behavior where light scatters in a way that defies standard surface models. Negative polarization at this intensity suggested a texture or internal layering never before confirmed in comets. Not dust, not ice, not rock. Something else entirely, something structured. Each anomaly alone would have sparked heated debate. Together, they formed a pattern. And now, layered on top of all of it, was the X-ray cloud, a 250,000-mile-wide halo of high-energy radiation, shining where no comet should shine at all. X-rays require violent interactions. Charged particles slamming into material, electromagnetic processes that demand complexity. Yet 3I Atlas was supposed to be a simple relic of interstellar debris, a frozen leftover, a cosmic snowball. It was behaving like anything but. Researchers began to speak carefully, choosing words that would not cause panic, but the unease was unmistakable. Something about 3I Atlas was interacting with energy, light, and charged particles in ways that current comet science could not explain. The models were no longer stretched. They were collapsing. The fear had shifted. The concern was no longer that scientists were missing details. The fear was that the entire framework, everything used to classify, predict, and understand objects like this, might be wrong. And as 3I Atlas continued its silent approach, emitting signals no one could fully decode, one question began to dominate every discussion behind closed doors. If this is not a comet, then what exactly is moving through our solar system right now? The answer may arrive in the next phase of its journey, and when it does, it may force scientists to confront something far more unsettling than a broken model. The alarm phase has begun. Inside control rooms across 2 continents, XRISM teams are no longer celebrating discovery. They are hunting for errors with near desperation. Every photon is being rechecked. Every detector pathway is stripped apart. Engineers know the stakes. If even one instrumental artifact survives this review, the finding collapses. But if none are found, the consequences are far worse. The X-ray glow surrounding 3I Atlas refuses to disappear under scrutiny. It persists through recalibration, background subtraction, and cross-instrument verification. The signal is clean. And that is exactly what terrifies them, because a real signal means something unprecedented has entered the solar system. The halo, stretching nearly 250,000 miles, does not behave like anything produced by normal cometary outgassing. It is too large, too energetic, too stable. X-rays should not linger like this around a small interstellar body unless a powerful, unseen interaction is taking place. One hypothesis points to extreme charge exchange reactions with solar wind particles. Another suggests internal structural processes releasing energy at levels never recorded from a comet this size. None of the models fully explain what the data shows. Each explanation opens more questions than it answers, and those questions are spreading fast. Planetary defense analysts are now quietly revisiting their assumptions. If interstellar objects can carry high-energy X-ray signatures, what else might they transport? Radiation-altered chemistry, exotic particle interactions, unknown surface reactions triggered only when such bodies encounter a star like the Sun? These are not abstract fears. Defense simulations rely on known physics. 3i Atlas is violating those expectations in real time, slipping through models never designed to account for this behavior. Astrochemists are equally unsettled. The X-ray emissions suggest processes that could radically alter molecular structures within the comet's coma. That means interstellar visitors may act as chemical couriers, reshaping material as they travel between stars. If so, then the building blocks of planetary systems, including Earth's, may have been influenced by forces science has barely begun to recognize. What arrived in our system long ago may not have been inert rock and ice, but something far more active. As days pass, the comet continues its silent retreat. 3i Atlas is already fading beyond the range where follow-up observations can resolve fine detail. No second chance is coming. No probe is waiting. The object that triggered this crisis is leaving before answers can be secured. Yet, its X-ray halo remains frozen in the data archives, bright, structured, and unresolved. Scientists stare at plots that refuse to flatten, signatures that should not exist, patterns that hint at mechanisms no one can yet name. The official statements remain careful. Words like anomalous, unexpected, and under investigation dominate every briefing. But behind closed doors, a harder truth is taking shape. This was not a harmless flyby. It was a warning shot from interstellar space, a demonstration that the galaxy may be sending us objects far more complex than we imagined. 3i Atlas is gone. But what it revealed is not. And as researchers begin comparing this event to faint, overlooked data from past detections, signals once dismissed as noise, a chilling possibility emerges. This may not be the first time something like this has passed through our system. It may only be the first time humanity noticed. The mystery is no longer about one comet, it is about what might come next.